Welcome to our lecture Energy Business. This time we talk about the wind power. Have a short look into history, something about efficiency and the wind resources, the converter construction, a word about offshore technology and the economics of wind power. So mankind started to harvest mechanical energy with wind, because wind is more or less easy to convert and it is available in sea, and so the ships had sails on them, and they have been very beautiful, the first sails, as we see in this picture. And one point is that sailing makes you really able to learn new countries, to new areas, and especially in Egypt the sailing boats have gone the river Nile up and down. That was very interesting for transportation. How long we exactly have sailing boats is not completely clear, but it seems that they are here for more than 5,000 years. This picture, by the way, is 3,500 years. And you see already the central elements. You see the sail here. You see a rudder to keep the direction. You see some person checking the water. For what reason, I don't know. Some more seems to have another part of a sail here. And he is helping raising the sail, because there are a lot of connections, and so you can lift the sail. Why was this the first way to convert mechanical power? We already knew thermal power from fires. Fires are much older, about 500,000 years. The point is, it is very hard to convert heat into mechanical power, so that has needed one long time. And the other mechanical power was water, but in these areas where the first civilization started, for example in Egypt and in Sumeria, there was not too much water available, different to the Black Forest. Now, to harvest this energy, there have been also windmills of an interesting type. These windmills worked vertical, and so you see here the spinning wheels that rotate, and by the shape of the walls here, and if wind comes in from this direction, it will rotate. And if you are in a good position, you can use the wind energy by these constructions, and you see they are more or less simple. You have large wood piles, and you have this wood for the moving part, and you have to build these walls here. That is quite some work, but you can harvest that, and then you can use that, for example, milling your grain. The type of windmills shifted then to more advanced systems, and the first time that we used windmills to convert the energy of a mill into electricity was in 1888, and this seems to be the mill. And what you see, they have very many blades. At that time the people thought it is useful to have this many blades. It was more or less slowly rotating, and they have also a rudder to keep the direction. That means that your windmill system itself, that is rotating here, is able to follow the direction of the wind. So this is spinning. This is to steer that. You see there is some mechanics in here, and to keep that always exactly into the wind direction. And in here, the gondole, there's the area where you have the electric energy conversion process. It's quite huge if you compare that to the person here walking with the dog. Maybe it's some 20 meters high. Now, how efficient is it to convert wind into mechanical energy? And this is an interesting physical question. And one point is the first is that wind power can never be 100% converted into mechanical power. And the point is, if the wind is coming here with an energy of 100%, that is the wind energy, then the leaving wind is still 40%. So why can't you stop the wind completely? Yeah, if you would do that, then where should the air go? The air has to move away, otherwise you are sucking up this energy. And now, so the windmill reduces the local wind speed. It cannot stop the wind, because stopped wind, where should the air go? So if you do the detailed calculations, we don't do, but there are some interesting findings. The first thing you have to imagine, there is a piece of air. So we talk now about this piece of air, and this piece of air is moving in the direction of a windmill. This piece of air has a velocity, and the energy of a piece that has a velocity is usually the mass of a system multiplied by the squared velocity. So now if you look into that scheme here, and you have a higher velocity, more wind is going through your system, and so if you talk about the energy of the wind, you can multiply that with the amount of wind you can go through here, and you have enough of V, and so you end up with a power of a third power of a velocity. So third power of velocity. This is the reason why people who install windmills always look for strong wind. Otherwise, it won't work. And that is underestimated because the third power is very strong. So if you have a double wind speed, that means you have 8 times more power. So let's write that down. 2 times the velocity results in 8 times more power. And that's the reason we need high speed. Many areas of the world don't have that. So if you look deeper into the equation, you see there's another factor, that is A. That is the area of the rotor. That is the area the rotor is covering. And if you want to have a bigger area, you have to extend your windmill. And extending your windmill gives you a big effect, because the length of the wind arrows is going into quadratic, because you have the area here. So what the people do today is they build huge windmills, because then this area is growing. The density of air, you have not too much influence, but it should be mentioned that at sea level you have a higher density than, for example, here in the mountains. So maybe about 10%. Then, the wind speed we have already talked about. The wind speed is growing if you go higher, so you can also expand your windmill system to a higher level by building a huge tower. So that is the chance you can optimize that system. But it is always clear that you only can use maximum 59%. Today the typical values are in the 40s, in the upper 40s, 42, 45, if you have very high efficient windmills. But as always, efficiency is useful, but if it is very expensive, so you may lose 1 or 2% of efficiency, but maybe the thing is 10% cheaper, so yeah, be aware of that. So common efficiencies today are in the range of 35 to 45%. And I think they won't go far away from that. It's a little bit similar to solar energy, where you also work with 20%. It's not perfect, but the input energy is more or less free. Now, where can you put windmills? So not every area in the world is sufficient for wind. You have typically the west wind in Europe, and so along the coastline you have always high wind. Here all down to Portugal, they are all in this wind area, and you see the coastal areas here, for example in Germany, and on the Baltic Sea you have a lot of wind. So, and the king of wind is here, I think, Great Britain. They have really a lot of wind, and if you look into details, you see Ireland is even preferred. If you look into the United States, you see the north has a lot of wind, but no one is living here, so we don't use that. There is a little bit in North California, and there is quite a lot of wind in the east of the United States and in the area of the large lakes. Then the king of wind in the world is South America, and especially Patagonia, where you have wind speeds in the area of 16 meters, 10 and more meters per second in the medium. That is strong wind. So all this area that is colored beyond the scale here. So there are some small places, for example in Somalia, in the Mongolia desert, here in north of Japan, in New Zealand, in south of Australia, and not to forget south of Morocco has some good wind, and maybe they can export that to us. In central of the Sahara there are also some spots, but there are also areas where you have no or only a very weak wind, and for example in South Germany there's not too much wind because we are far away from the coast, so it doesn't make too much sense to put windmills here in the Black Forest. That is more or less wasting money. No wind is in the areas of the tropic rainforest, and if you look exactly, this is the equator, and along the equator you have no wind. The reason is most of the wind is generated by the Coriolis effect, that the Earth is spinning, and if air is going south, it usually goes then to the west, and so we have wind here. There is one area to mention also, that is Greenland, and Greenland has this high wind gust, and by the way the Chinese brought some areas already in Greenland for building wind parks. Let's see if that works out, but you can transport then the power to Europe. Maybe that's the next generation of wind energy. Now looking into the different ways how to put the windmills, here is a picture I took in Mongolia. It is a set of windmills on top of a hill, and this is an area where you have always high wind. I've already mentioned Mongolia, and it is more or less easy to transport the windmill to these places. So advantage is, if you put it on hills, the wind speed up here is very high. Then you have the first effect is the hill, and the second effect is that you mount them on a tower. So you have a tower and you have a hill. That is very suitable if the hill isn't too wide. So you see they put them on top of that hills. We don't have it exactly here. The problem here in the Black Forest is quite huge. This is a mounting of a windmill near the Kandel. The first thing is you have the trees, and the trees eat up the first 30 meters of wind. So you have to build your tower, that is by the way the tower, at least 30 meters, otherwise you won't have any wind at all. Then you have to build a huge construction. So this tower is in the range of 150 meter. That's not trivial. The base of that tower is in the range of 15 meters. So it's a big tower. By the way, the place inside of this tower is used for the transformator. And you have these blades. The wind blades are in the range of 60 meters. So that's huge construction work. You need huge cranes, very specialized cranes. And the transport of that cranes is already some logistic problem. Here you see the crane in full shape. So the crane has to be as high as the tower will be, and the gondola, and then you put the windmill here. So this is in the range of 150 meter. And here you see the problem. The forest is eating up your first 40 meters. So the tallest wind turbine that you'll find is here named with 178 meters, and the tips, because they are long, are 246 meters. By the way, you get in interference with airplanes, and so it's not allowed to put windmills anywhere where airplanes are in the range of an airport, and you have to put some lights on them so that you can see the windmill at night when the airplanes are flying. That makes them a little bit optically noise, but yeah, there are new rules coming in that these lights are only shut on when an airplane is coming. Interesting technology. So yeah, the Bögel built the largest, the tallest wind turbine near Ulm, by the way. So the logistics of onshore wind is also a trouble, especially for transportation. And here you see the wind blades, as I mentioned, they are 60 meters long. And to bring them into the mountains, for example, where you have the nice hills, you usually don't have the wide highways. You have small streets in the towns and villages, and you have to keep care of all the things that are left and right of this street. I remember one time I've driven back from Zurich airport in the night, really at night, 1 o'clock, and then the police stopped me and they told me that I have to wait 1 hour until these trucks are gone through this small town, Bloomberg it was in that case. That is a really challenge for the transportation logistics. Makes things a little bit more expensive. So if you are in a flat area, things are not that difficult. So at the North Sea, typically the area is flat in Dutch and in Germany. So you can much easily build them. Here you see a so-called repowering process. New high pillars are built here. That is the old ones. They will be tiered down. And the old ones may be 70 meters and the new one may be 150. There is some environmental problem. The first question is about the birds. Some birds are just loving to fly in that height. For example, the eagle. He wants to catch animals, and so he usually is flying 100 or 200 meters high, and if he doesn't care about that, he will be killed by the windmills. Another problem is noise. There is a big discussion about the so-called infrasound, that is a frequency below what you can hear. Some people tell that this is dangerous. I can't judge that, but maybe. Then the landscape is really changed, because if you put towers into the mountains, that is not the original landscape. And you have some space demand. So to generate this, you have to seal some surface here. The reason is you need a place, for example, in the forest where you can put up the crane at the construction time, but you have sometimes to repair something, and then you need that place again. So the place here is in the range of 100 square meters for the sealed surface and for the crane, so you can talk about 300 square meter for a megawatt wind power, maybe even more, I don't know. And of course you have to put the access roads here, because in the typical place where you put the windmill you don't have the roads, so you have to build all this new road system. Not perfect. There's another way to do that, and then you go to a place where you don't have to care about roads, where you don't care about mountains, and we have really a lot of wind, and that is the offshore world. So if you can go offshore, that's great. Why can we go offshore? The reason is some areas in the sea have a very shallow water depth, and so although we don't see it exactly because we are never diving that, a typical area in the North Sea is only 20 meter, 30 meter, but not really deep. And below that is sand, and you could put the windmill into that place. So the difficulty there is that it is not clear what type of mounting at the sand here is the perfect way. So there have been developed a lot of technologies for monopile, that you put a pile into the sand. That seems to be the preferred way. You can put a big chunk of concrete there. You can have this base thing. You can put a type of tower there. You can put that in different piles there, and so on. There have been experiments. As far as I understand, the preferred way in the moment is to use piles. You drill the piles into the sand, and that makes them quite stable. But it is noisy, and the animals, whales and dolphins don't like that. So, but they have learned to start very with small hammers, and then the big animals like the whales are going away, and then you can get louder and louder, and you don't disturb them too much. So another big advantage is if you go offshore, that offshore the transport gets really easy, because you can do that by ships. Ships can load huge stuff, and so that's not a big problem to bring a windmill to that place. So what you do is you take your ship, and you have all the equipment on the ship for installing a windmill there, and you can put also cranes on there to organize all that. So one problem is there, of course, because you want to go to an area where there's a lot of wind. You need a time that there's no wind, and so you have short windows for the mounting, so you have to be fast. So sometimes the weather situation is that there's no wind in the North Sea, so within 1 or 2 days you should install that stuff, then it works. You can't wait you cannot install that over weeks, because then you have stormy weather, and that's difficult. So, but the advantage is the very strong laminar wind. It's perfect wind, because the wind is really flowing always constant in the direction. There are no turbulences. Now here are some numbers about huge wind power. So the height I already mentioned is in the range of 200 meter. The diameters of these rotor systems are today beyond 200 meters. The diameter, so the length of the blade is maybe 100 meter or 120, 110. The surface is in the thousands of square meters. So compared to 7 football fields. This is an advertisement from General Electric, but I like that this is showing you really the shape we are talking. And one 12 megawatt generator can produce 67 gigawatt hours annually every year. That is quite some money, because if you pay 10 cents, or maybe say you will only earn typically $50 per. Let's do the calculation to get an idea what's going on here. we have typically a price of $50 per megawatt hour. So that is 1,000,000 times that, 50 gigawatt hours. So that generates you about $500,000. Yeah, if you can make it with that high price, you usually have to install all the infrastructure, cables and so on. Now that makes it tricky. So now look into the cost structure. What you need are different things, and the first is you need the turbine itself. Then you need this transportation, logistics. As I already mentioned, logistics is not trivial, especially on land. And we are talking here about sea. You need a supportive structure, so what's going in rammed into the sea. You need the electrical infrastructure because there's no power plug-in for sea, and you have to do the construction financing and some development service. That's small. And so if people say that the wind turbine is cheap, that's not the whole story. It's only 34%. There have to be done other things that make things quite expensive. So the near shelf installation of wind turbines is the one thing, but near shelf is not always as shallow waters as in the North Sea, where it is really excellent for installation. There are a lot of ideas to go really into the deep sea area. Deep sea has many advantages because there's much more deep sea in this world than shallow waters, and we can bring the turbines to places that are really under high wind conditions. So, and we talk about deep sea if we have more than 50 meters, then it does not make any sense to build piles that deep, or you have to know that the sea usually has a shelf area around the continents, and then the deep sea is really starting quite fast, and so there is no 100 or 200 meter that is useful. So there are now different ideas how to do that. You can have a barge that is more or less a ship that is swimming in some way, and you can have this semi-submersible installations, or you can have a spar that is a very deep and heavy cylinder that has a lot of weight down there, and you also can try to have tension lines down there, and there are many different ways to convert that and to build that constructions. Actually, there are only very few cases where it was really done, because mounting in deep sea is expensive, and as long as you have still enough shallow waters, then you don't go to the deep sea. But on the long term, it might be an interesting idea. Now we have to compare onshore and offshore systems, and there are different points we have to think about. So let's look into the onshore situation. So the first thing, there's everywhere something onshore, so you can go to some places. The mounting is not that difficult because you don't have to go to sea. You usually have an easy grid connection. That is a big advantage. And the maintenance is also easy. So there are some problems, the environmental problems, because people don't like wind turbines in their backyard. And there are problems like killing birds and sound effects, and some ice throwing. If you are in the northern area, wind turbines may throw ice, so you have to close some areas for visitors. Then you have a lot of fluctuation, and the hardest problem on onshore is turbulence. Especially if you go in the mountains, the wind is not so simple and laminar than it is on the ocean. This makes turbulences, and turbulences destroy the wind blades because they generate strong material vibrations. So typically you have low capacity because most of the time on land you have not too much wind. And if you are direct at the coastal region, that works, but on most areas of the land you have low capacity, really compared to sea. And you need a lot of infrastructures, especially you need streets, because you have to bring all the heavy equipment, and you remember the crane, to that place. And yeah, if you think here about the Black Forest, there are the small roads for moving the trees, but it's not sufficient. You need really to move heavy equipment, and that may be a stress to your roads and needs additional infrastructure, especially in areas where you don't have any roads at all. So then what is the advantages offshore? The real big advantage is the strong wind and the low turbulence. That is a perfect area. You have thousands of hours during a year, so a typical comparison here, but that is for Germany. The wind in the North Sea may go up to 6,000 hours, and wind on the coast and on onshore in Germany is maybe 1,500 hours. So you have a real big difference here, 6,000 against 1,500. So by the way, 8,800 would be a full year. That is never available at no place. So this results in a high capacity factor, that your wind turbine is really working, and the landscape is not a big problem. That's not completely true, but of course there are even people who don't like it to see the wind turbines from the coast. If you are have a very nice coast area, for example Sylt in Germany, they had protests and they had to go 80 kilometers away from the coast so that it is just invisible. Big problem in offshore is the maritime environment. So maritime environment is the roughest environment you can have on Earth, and no one wants to build anything there. You have to build ships for that, but ships are a different thing. The one thing is for salt water. Salt water is corrosive, so you have to keep care that no salt water is entering your equipment. And so the housing of a wind turbine is usually done in an overpressure, so that there's always pumped fresh, clean air into the housing system of the wind turbine, so that no salt water, in what type ever, can enter the system. That needs additional power, not too much, but you have to be really careful. So maintenance is expensive because you have to go there by ship. You have harsh conditions and you have all the time the wind. So if there is wind, you can't maintain it at all. So you have to look for a few hours in the year when you can do the maintenance. So you have to produce systems that are very long withstanding this harsh environment. And the grid connection is expensive because you have to go by cable. Cable is much more expensive than typical power lines. Factor of 8 is sometimes named, but I'm not quite sure that this is always doing the same. The advantage here in grid connection is that no environment protection is a problem because you can put them into the sea. That's not a big problem. So depending on the situation, yeah, some things are an advantage, some are a disadvantage. Now the economies of wind power is a difficult thing, and it is very strong related with wind speed. And so let's look into that and look into the speed of the wind and in the number of hours you have. So the red line tells you how often you have different wind speeds. So the most often wind speed is here, maybe something about 5 meters. So, but 5 meters wind speed gives you only a small amount of energy. You remember the third power in this power law. So this often appearing wind gives you only a small amount of power. But the high winds here in this area below, above 10 meters, so let's say 12, this gives you only the few hours you have. So a few hours here, you have only 150 hours, but you can earn most of energy in this time. Here you have this is 500 hours, but it doesn't give you as many energy. So then you can calculate that. You ask for the full production divided by the hours of a year. That is a so-called capacity factor. And depending on your type of windmill, you can make offshore a lot of energy. And so you have to understand the red line for a place. And it's not simply by adding up the hours, multiplying it by the wind speed, and then you say our mean wind speed, for example, is 7 meters or so. You have to do the whole integration over this blue curve. Then you get a fair calculation. So you have to keep in mind that the velocity is going in the third power into the energy. Or let's say the power is going into this, because we are talking about power generation. Power is proportional to the third power. And here this axis is speed here. So yes, you have to calculate that for an optimal generator, and you have to look what is your highest wind speed when you can have a cutoff. Somewhere here you say the wind speed is higher than my equipment can withstand, and so wind speed beyond 25 meters per second, that is stormy weather, you shut down the turbine at all, so you don't collect energy beyond that wind speed. That is safer for your system. So yeah, that is the tricky position to do the economics in a special place where you collected wind speeds. By the way, collecting the wind speeds itself is very tricky, because typically you don't know the wind in 100 meter height or 150 meters, and you have to measure that. And if you are in a mountain area, the wind speed will change within 10 kilometers quite strong, and so you have to clarify that situation. Now there are some capacity factors, and the interesting thing is that the windmills are finding better and better places. So we look into different years here, and let's see what is the capacity factor during the years. So in the 90s of the last century, we had typical capacity factors of 25. Windmills were not installed at the best places. They had not enough knowledge about that. Then things got better, 34%. And then there was a lot of wind hype, and things a little bit decreased because they put windmills just everywhere. Today, no, that's not really exactly today, but it is growing now up to 40%. 40% seems to be a possible level, but this is by finding good sites for the system, and in addition, higher towers, better blades, and better systems itself. So this all collected together has changed the results. So today we have now about 40% of the possible energy at a site. That is quite a lot. Now the second thing is, beside how much power you can have, you have to ask about the cost of the wind installation. And here we have a long-term study about the costs. So it starts 1982, and the cost in dollars per kilowatt, that is the point. So it is calculated for the year 2017, but yeah, you can calculate dollars from earlier years. So here in the early days, the cost of a windmill per kilowatt hour was in the range of $5,000. Then you see the line really dropped. Then there was a time where things are going flat, and then there was this hype about 2008 to 2011. Things get a little bit more expensive, and now they are still dropping again, because now there are sufficient many companies producing wind systems. And if you look into the projects, and so these projects are typically today in the range of maybe $1,800. This is, that should be mentioned, for the US. We have different areas, the Great Lakes, northeast, west, and southeast, because the different areas have different wind speeds. So this is, by the way, mostly Texas and the area of the Great Plains, the western part of the Great Plains, where you have a lot of wind projects up to 50,000 megawatts now installed at 2017. Some more thing is here shown, that shows you, the circles show you how large the project were, and yeah, the bubbles give you an idea how large the project were. And now we are talking about the levelized cost of a levelized PPA price. What is a PPA price? Now the levelized a PPA is a private public agreement where you say, okay, I produce energy for one price. Let's say this site here is able to produce energy for $50 or something like that. If you are better, and so you see things get better, you are now today, you are in the area that you can produce wind energy below $20. And $20 is really a low level, because there are only a few technologies that can produce energy at all for that price. And so you see there has been a dramatic decrease in the price, and now it flattens out a little bit, and the system sizes are quite huge. You see these big cycles here. In the early days we had a lot of small systems. Now, what's about the world? So let's look at the worldwide energy generation capacity. We are talking about the capacity. The capacity installations have gone up, but this plot doesn't tell you the whole story. It is better to have a logarithmic scale, and you see there is more or less an exponential growth of the wind power. So exponential growth, that can be seen easy. The exponential growth, you see this here in terawatt hours, is a logarithmic scale. And if you have a logarithmic scale here and a linear scale here, you see the typical exponential straight line. Or if you do that in a linear scale, you see this amazing growth of the bars. At the moment, there are some, this is 2018, the last numbers I have here. We have 600 gigawatt installed capacity. That is quite a lot. Now we are going near to the terawatt now, but it is still small compared to other installations. So we are talking about something like 5% of the energy is now coming from wind. And now finally I want to go in another topic, and that is high altitude wind power. High altitude wind power is a very charming thing, because if you go in a high altitude, the energy is great. Why? Because in high altitude you have strong winds. And there is a map here, and that shows you how much kilowatts per square meter of wind turbine blade you can produce. And typically levels here in this green area are in the range from 5 to 10. That is much more than you'll find in any area on ground. Reason: there are strong wind streams in the area of the north and the south land. So here we have this area of strong winds around the 45th degree, and here the same. So in the region of the equator you have just no wind, it's calm. In the very north area you don't have also no wind. You have also no wind, but in some regions, for example, the south of the African continent, or in the area of Japan, or by the way near New York, you have extremely strong wind. So why not put a windmill that high, maybe in 1500 meter? So typically high altitude is 1500 meter or higher. Yeah, but you don't want to go too high. About 10 kilometers is difficult, because there you need a very long line, and you have problems with the airplane. So that is one of the problems here. If you install a wind technology that high, you interfere with air traffic. So you have to close areas where you say, I don't want to see any airplane here, then I can put my wind system up. That is a difficult decision. And the other thing is, the equipment up in the air has to be light, otherwise it does not fly, and it has to do a long duration. And so this is a contradiction. And all these tests here with very smart ideas, having here, for example, this propellers, that was a Google project, by the way. It was done by Google. It is now stopped. They have seen that doesn't work out. There are more or less fantastic ideas to have spinning wheels with parachutes or whatever. Or this one having a lot of blades up there, looking a little bit like a quadrocopter connected by a wire here. Finally, none of that projects really succeeded. Is really working. There are experiments, but not really working. So that's a little bit about wind, and thank you for your attention.